Good morning. Today we'll be covering Module 5, Lesson 3, and this is the fluency portion of the lesson. So we're going to cover the lesson objective for today, and that is I can decompose non-unit fractions and represent them as a whole number times a unit fraction using tape diagrams. So this means basically we're going to be breaking apart non-unit fractions and converting them, or changing them into a unit fraction times a whole number, and we'll be showing this using tape diagrams. So we're going to start off with some mental multiplication. So first we have 2 times 32, and so I can just come over here and I know 2 times 2, that gives me 4, and then 2 times 3, and that's 64. Makes it 64. Alright, now I'm going to do the exact same thing, but if I take this 0 over, I know 0 times anything is just going to give me 0. So I'm just going to go ahead and put a 0 here. Then I'm going to come back over here and 2 times 2, and that's going to give me 4. And then 2 times 3, and that's going to give me 6. Now, if you look here, we're basically just adding these two together. So I could either multiply them here, or I can just add these two up. So this is going to be 4 plus 0 equals 4. 6 plus 4 equals 10, carry the 1. 1 plus 6 equals 7. So, you can confirm this by going 2 times 2 is 4. And then we know that this 2 times 6, or 3 will give us 6. Then we put that up there. So if I was doing it this way here, I was doing it the standard algorithm. We know that 2 times 2 gives us 4. 3 times 2 gives us 6. 2 times 2 equals 4. Let's put our placeholder 0. 3 times 2 equals 6. And we add it up. 4 plus 0 equals 4. 6 plus 4 equals 10. And 1 plus 6 equals 7. So, same thing as always. You can add them together if you've broken it apart like that. Or you can just do the standard algorithm. So, whatever makes the most sense to you. But you can do it in your head if you just break them apart like that. So, alright. Moving on, we're going to do the next one. We have 23 times 3. Well, we can do 3 times 3. That gives us 9. And then 3 times 2, which gives us 6. Now when we move to the next one, it's going to be the same thing, but we're going to add a 0 to it. So I have a 0 here. 3 times 3 equals 9. 3 times 2 equals 6. And then we're going to basically do the same thing. If you'll notice, they just basically took 33 and they broke it up into the ones place and the tens. So you're still basically doing the multiplication like we were doing the standard algorithm, but you can do it in your head, and so we can just combine these now. So we know that 23 times 3 equals 69, and 23 times 30 equals 690. So when we add these together, we get 9 plus 0 equals 9. 6 plus 9 equals 15. Carry the 1. 1 plus 6 equals 7. And then we have 12 times 4. So 4 times 2 equals 8. And 4 times 1 equals 4. Now we're going to do 12 times 30. So we know that the first digit is going to be 0 because 0 times anything will give us 0. Now we do 3 times 12. Well, if you know your 12s, you should know that's just 36. Now it's going to ask us 12 times 34. Again, we've already broken this up and we can already do this. So 8 plus 0 equals 8. 4 plus 6 equals 10, carry the 1, and 1 plus 3 equals 4. Alright, now we're going to be doing repeated addition. So 2 plus 2 plus 2 equals 6. Blank times 2 equals blank. So basically this is saying it wants us to rewrite this equation but use multiplication instead. And so we have 2. How many times do we have 2? We have 2, 1, 2, 3. 3 times. So we know that 3 times 2 equals 6. Now we have 30 plus 30 plus 30. Well, that will give us 0, 0, 0, gives us a 0. 3 plus 3 plus 3 equals 9. So, if we were to rewrite this using multiplication, how many times do we have 30? 3 times. 1, 2, 3. So 3 times 30 equals 90. Then we have 32 plus 32 plus 32. So if you'll notice, we're just combining these again. So we know that 2 plus 2 plus 2 equals 6. And then 30 plus 30 plus 30 equals 90. So that's going to give us 96. So when we rewrite this, we have 1, 2, 3. 3 times 32 will give us 96. Alright, 1 plus 1 plus 1 plus 1 equals 4. So how many times do we have 1? 1, 2, 3, 4. 4 times. 4 times 1 equals 4. 20 plus 20 plus 20 plus 20. That should give us 0 plus 0 plus 0 plus 0 equals 0. 2 plus 2 plus 2 plus 2 equals 8. So 1, 2, 3, 4 times 20 equals 80. So when we have 21 plus 21 plus 21 plus 21, again, we're just combining these. We should have, 84. And so we know that 1, 2, 3, 4 times 21 will give us 84. Alright, so now we have 3 plus 3 plus 3, which equals 9. So 3, 1, 2, 3 times 3 will equal 9. 20 plus 20 plus 20 equals 60. So 1, 2, 3, 3 times 20 equals 60. So now we have 23 plus 23 plus 23. Well, that's really just going to give us 69. Oh, where is this? Where'd my pen go? 69. Then we have 1, 2, 3 times 23 will give us 69. Alright. Finally, we have, we are adding fractions. So we're looking at the tape diagram and figuring out how much of the shape is shaded by looking at the tape diagram. Well, the first thing we know is that this whole thing is equal to 1. Then we've got 1, 2, 3, 4 out of 5. Well, that's what it says. We have 4 out of 5. So now we're going to write the unit fractions to show this addition sentence. So we have 1/5 plus 1/5 plus 1/5 plus 1/5. So it's showing us how much each unit or box is worth. So we have 4 boxes out of 5, and when we add them up, add the unit fractions up, we should get 4/5. So 1/5 plus 1/5 plus 1/5 plus 1/5 should give us 4/5. Alright, so now we have the same thing. This whole thing is one whole. But it looks like these two brackets are joined together. So how many is this unit worth? Well, this is 1, 2. So 2 out of 5. Then how much is this one worth? 1/5, 1/5. So when we write this, we have 2/5 plus 1/5 and 1/5. Alright, and on this next one, we have a unit of 1, 2, 3. So we have 3/5, and then we have 1/5. So when we write this, it's just 3/5 plus 1/5. And there you go. Alrighty. So that's it for this video. And after this, go to the application problem video. Alright,